Hi, today we are going to see lecture 6 Digital Principles and System Design. So the topic to be covered in lecture 6 is sum of products. It's a very important topic in your digital electronics, and this is very loud. So in this sum of product, how to mention this, what are the terminologies we'll be using, and how to convert the sum of product into a minimal number of sum of min terms, everything we can see it here. So sum of products means occurrence of a Boolean variable either in what original form or in a complement form is called as a literal. So in a given Boolean function, if each and every literal, every alphabet or every variable, Boolean variable is said to be the literals here. And here these literals can be arranged in two different forms. One is your sum of product, other one is going to be the product of sum. So in this lecture, we are going to see the sum of product alone. So sum of product means a Boolean function will be expressed in terms of a group of a product term, and all this will be combined with the help of your OR gate. So you know that product term will have your and then addition of all these things will be done by the OR. So that is called as a sum of product. So from this itself you can get sum of products. So all the products will be summed, that is sum of products. So here you have two different forms. One is going to be standard form, other one is going to be the canonical form. So what is the standard form now? So whatever, just f is equal to ab bar plus bc bar plus ab. So your function with the Boolean variables is said to be the standard form. And here all this term, this is going to be each and everything you have three product terms, and all these three products will be summed together or combined together using your OR operation. So this is called as a standard form. So A is one literal, B bar is another literal, B is a literal, C bar is a literal. So these are called as a literal. And here how many variables I have? I have three different variables, A, B and C. So either in original or in complement form. So this is what you have to identify. While you are seeing a Boolean expression, you have to see what is your input variable, what is your output variable, how many input variables you are going to use. And what is a canonical form means each and every term should have all the variables here. For example, in this one, I said that we have three input variables, but in this term, your variable C is missing. In this term, variable A is missing. In this term, variable C is missing. So this is called standard form. In canonical form, each and every variable should have, each and every term should have all the three variables either in original form or in the complement form. So this is an example for the canonical form. Here I have three terms and it has three variables. So all three variables are present in each and every term either in original or in complement form. So this is your canonical form. So these two forms you have to keep it in mind. So this canonical form can also be said as sum of min terms. Sum of min terms. So either they may ask you to find canonical form or sum of min term. So what is the procedure? We will see what is how to get your min terms, sum of products here. So find the min terms of for the function f is equal to ab bar plus bc bar plus ab using the truth table. So how many different variables you have? You have three variables abc. So if you have abc now, how many different combinations you'll get? 2 power 3, 8. That is going to be, this is said to be your m0, that is your m0, m1 and m2, M3, M4, M5, M6 and M7. That is a min term. Right. So now you have to get your values of each and every um, term. How many terms, different terms here you have. So first is going to be your A, B bar, then B, C bar, then A, B. Find the value of each and every term. So we saw this one in the last lecture itself. So it's going to be A, B bar is 0, 1. So 0 into 1 is going to be 0. Then B, C bar is going to be B is 0, C is 0. So C bar is 1. So 0 into 1 is going to be 0. AB is 0 into 0 is going to be 0. So function f is going to be the combination of all these three. So next is going to be 0, 0, 0 and here it is 0. Next is going to be 0. Then it's going to be B, C bar. B is 1, C is 0. So C bar is 1. 1 into 1 is 1. AB is going to be 1 is 0 into 1 is going to be 0. So the addition of these three is going to be your 1. Similarly, we are going to find the values for each and every combinations here. So at last we after finding this combination here, how to write the min terms now? The function f which is going to have 1 is called as a min term. So this one is going to have the min term. What is the value here? M2. And this is min term M4, and this is your M5, M6 and M7. So I can write the sum of min terms as summation. You have to put it in the summation. The summation tells you it's going to be sum of min term or sum of product. So in this one, what are all the things becomes the value is 1. So here it's going to be 2, then it's going to be 4, 5, 6 and 7. So I'll be writing it as a 2, 4, 5, 6, 7. Or I can represent it in another way also, that is M2 plus M4 plus M5 plus M6 plus M7. M should be a small letter. Then or I can go for this way. So this is your M2. 2 is 0, 1, 0. So A bar, B, C bar. And your 4 is 1, 0, 0. A bar, sorry, A, B bar, C bar. And M5 is A, B bar, C bar, C. And 6 is A, B, C bar. 7 is A, B, C. So sum of this term. So these are the three different ways of representing the sum of min terms. Okay. So now we'll see how to convert the sum of products to a sum of min terms or canonical form. So the procedure is, first one, find the missing literals in each and every product term, and that min term should be replaced by 1, and then this 1 will be replaced by the property, inverse property. If the whichever literal is missing, that property you have to use. And then you expand the term by applying distributive law, and fourth, remove the retardant term. So you will be getting your canonical form or sum of min terms. So we'll solve some problem here. F is equal to A bar plus B. Convert SOP into a sum of min term. So in this is a Boolean function. So with the how many input variable here you have? Two input variable A and B. So here this is said to be a sum of min term. But here in this term your min term Boolean variable B is missing, and in this term your Boolean variable A is missing. So what is the first term I have identified? In this term B is missing, in this term A is missing. Now I will be introducing 1 to it. So in the place of B I am introducing 1, in the place of A I am introducing 1. So this should be replaced by the inverse property. Here B is missing, so B plus B bar. Then A is missing, so A plus A bar. And then you expand this one applying the distributive law. So A into B plus A bar into B plus A bar into B bar. Similarly, A into B plus A bar into B. After getting this one, your fourth step is to remove the retardant term. You just see any term is repeating. Here A bar B, here you have A bar B. So I can remove the retardant term, one term, and then I can write it. So now this is your canonical form or sum of min terms, where all the term is having all the Boolean variable either in one form or original form or in the complement form. We'll solve one more problem. So I can represent this one as, so here it is going to be min terms. This is going to be 0, 1. And this is going to be 0, 0. And this is going to be 1, 1. So 0, 0 is going to be 0 decimal value. 0, 1 is going to be 1. 1, 1 is going to be 3. So 0, 1, 3. So one more problem. Convert the Boolean function into a canonical SOP. F is equal to A plus B bar C. Here, how many Boolean variable? You have 3 Boolean variable A, B and C. So here in this term B and C is missing. In this term A is missing. So I have identified and then I have replaced that one by 1. Now I have to use your inverse property to replace this one here. So here it is A plus B, B plus B bar, here it is C plus C bar, here it is A plus A bar. Now I can multiply this AB and then AB bar, then again I can go for it. So A into B plus A into B bar, C plus C bar, and here it is A into B bar C, A bar into B bar C bar, C. So now again this term should be multiplied. So AB C, AB C bar, AB bar C, AB bar C bar. So I got the entire term. I got 6 terms now with all 3 variables in all the 6 terms here. So now I am just checking for the retardant bits. So in this one, any retardant bit is there or not. So here this A B bar C, A B bar C. So I can remove one term. So I'll be having 5 terms: A B C plus A B C bar plus A B bar C plus A B bar C bar plus A bar B bar C. So this 5 terms is having all the three Boolean variables in either one original or complement form. So here, how can I write it in another way? So A is 1, 1, 1, 1. Here it is 1, 1, 0. Here it is 1, 0, 1. And here it is 1, 0, 0. And here it is 0, 0, 1. So what it is, 1, 1, 1 is the binary value 1, 1, 1. Decimal value is 7. This is 6. This is 5. This is 4. And this is 1. So I can write the min terms canonical form as summation. So here it is 1, comma 4, comma 5, comma 6, comma 7. So here I have given the practice problems as three problems here. So either they can ask it to convert the Boolean expression into sum of min term or to the canonical SOP. So here it is, here sometimes they may give your input variable in the bracket. So you can see it is a 3 variable, right? Whatever they are using with literals, that is a Boolean variable, that same Boolean variable is used to solve the problem. If they are given x plus y, x, y, z, have to use same x, y, z. Instead of that, you cannot take a a, b, c. You have to keep that point in mind always. So here this is going to be 3 variable. Here this also 3 variable. This is going to be a 4 variable. Thank you guys. Have a nice day. Subscribe my channel for automatic updates.